Hey class, today I'm at Fremont Indian State Park. This is located just off of I-70, kind of by Richfield. So I'm going to contrast a bit here. In this one, I wanted to show you some volcanic rocks. This formation behind me, it's called the Jolot Tuff. And it was formed from a giant explosive caldera that was just south of here over, I guess south of I-70, kind of above Beaver, a place called Mount Belknap. So this type of rock is called an ignimbrite. It's hard for me to say. So this is formed from what's called a Plinian eruption. You might be familiar with Plinian eruptions, even if it doesn't sound familiar to you. I'm sure you've all heard of a little place called Pompeii in Italy. Well, that town was covered by an ignimbrite from a Plinian eruption. In a Plinian eruption, it's very powerful, very explosive, and it shoots really high into the air, shoots a bunch of ash really high into the air. Well, that ash, it's basically small little pieces of rock. It has to come down eventually, and when it does, it's still really, really hot. It compresses the air below it, creating kind of like a hoverboard plane for it to move down. These Plinian ash flow tuffs, they can travel at speeds up to over 100 miles an hour, and they are hot and they do destroy everything in their path. So what we're seeing is the petrified remains of this Plinian eruption here at Fremont Indian State Park.
Hey, so now I'm here at Bryce Canyon National Park. This viewpoint is called Fairyland Point. The rocks we see here are really colorful, as you can see. They come from what's called the Claron Formation, and this formation was deposited about 50 million years ago in a giant lake that covered much of southwest Utah. So you're probably thinking, okay, why is it so colorful? Well, first off, that is caused by minerals that are within the sediment. Minerals like manganese, iron, and sulfur. So you know iron, when it rusts, it turns red. We're kind of seeing that same effect here with these rocks. So how do we know that this formation was actually deposited in an ancient lake? Well, if you look closely at the rock, you can see that there are all sorts of different layers. Those horizontal lines represent the bedding that was occurring within this lake. And you'll see different beds of limestone, mudstone, some sandstone. Well, if you can compare these to a modern lake, such as Utah Lake, you'll see the same sort of bedding occurring there. You'll have lots of layers of limestone, you'll have some layers of mud, some layers of sand where the river is running into the lake. So you can compare things that are occurring right now to these ancient deposits. This is called uniformitarianism. That basically means that the present is the key to the past, or the processes that we see going on today also occurred in the past, in this case many millions of years ago. So these pillar type structures, these are known as hoodoos. And you're probably asking, well, how did these form? Well, you'll notice that you can see a lot of horizontal lines, which, as I mentioned before, is bedding. But then there are also a lot of vertical lines. Those are called joints, and those occurred as the Colorado Plateau uplifted. Well, these joints, these are zones of weaknesses where water can get into. And when water freezes, it forms ice. Ice expands, and that breaks the rocks apart a little bit. And little by little, as the rocks break apart more and more, it creates these fins and hoodoos that make Bryce Canyon so famous.